Hello guys, welcome to today's summarized tutorial. I'll be taking you on a very interesting topic today, separation of mixtures, part B. Alright, let's jump into it. If we want to separate mixtures, we need to understand the kind of changes that these mixtures undergo. Basically, every substance undergoes two types of changes, either chemical change or a physical change. So let's take chemical change. A chemical change is a change that a new substance is formed and it's usually irreversible. Okay? When I mean irreversible, I mean you cannot change it back to the way it was. Example, burning of paper or wood, slaking of lime. Alright? Now let's look at this diagram. In the part of chemical change, you can see before, during, and after. Before we had a wood log, or you say log of wood. Then, after burning took place, it turned to a pile of ash. Can you see that a new substance is formed? Alright, let's move to physical change. A physical change is a change that no new substance is formed and is usually reversible. That means nothing new is formed, okay, and you can reverse it back to the way it was. Example, dissolving, or you say dissolution of common salt in water, melting of candle wax, melting of ice. These things are physical changes because nothing new is formed. Let's look at this diagram. We have a whole lemon, okay? When you slice it, that is during the process of the change, it still remains lemon, all right? The same substance, nothing new is formed. If I melt ice, I will still get water, the same water, okay? So basically, physical change, no new substance is formed and it's usually reversible. Okay? And the next, difference between chemical and physical changes. Physical changes, no new substance is formed, while under chemical change, new substance is formed. Under physical change, if you look at this table, I said physical changes are mostly reversible, while chemical changes are mostly irreversible. Okay? I said the substance retain its chemical properties under physical change. It doesn't have anything to do with its chemical properties. It is intact. Nothing is changed. But under chemical change, the new substance formed have a different properties from the original substance. That means the new substance formed will have entirely different, properties. Just like the example I used, wood and ash. All right, let's move to the next. Meaning of separation techniques. In this part of the class, we'll be talking about those techniques, those processes that we use in converting, separating mixtures into the different solutions. So, separation technique is a method that converts a mixture or solution of chemical substances into two or more distinct product mixtures. Or you basically say, separation techniques is a technique used to separate mixtures using physical methods or physical processes. All right, let's dive into this. The first one, evaporation to dryness. This can be used to recover a solid solute from solution by heating to dryness. So when you heat the mixture of solute and liquid, we tend to sacrifice the liquid, or you say the solvent, and we recover the solute. You can see in this diagram, we have a mixture, solution of both solid and liquid. Then it is being heated using Bunsen burner. All right. Then the water vapor goes off, leaving behind our salt in the evaporating dish or beaker. You get what I'm saying, right? Okay. So in this process, we sacrifice the solvent, leaving behind the solutes. All right. Number 2, distillation. It is used to recover a solvent from a solution. Okay, this method actually uses the principle of boiling point. All right. So if it gets to its boiling point, the solvent will be separated. So we don't sacrifice solvent in this method. Rather, we recover solvents. All right. So look at this diagram. We have this round apparatus, okay, is our round bottom flask. Then we apply heat using our Bunsen burner. Then the salt and water will begin to boil at 100 degrees Celsius. Leaving behind the salt, the water will be evaporating. Then we have our thermometer, which is used to measure the temperature so that we can be certain what substance is going out at that particular temperature. So if you get to 100 degrees Celsius, water will go out and it goes through the Lebesgue condenser, or you call it condenser. What the Lebesgue condenser does is to convert the water vapor back to liquid by cooling it. Okay, so we use cooling water to cool it back from being a gas to being a liquid. So in this case, we recover solvents. We don't sacrifice them. Then the water is then collected. So that water collected is called distilled water. Okay, or you say distillate. All right. Now the next, fractional distillation. Okay, this is used to separate such a mixture into, separate mixtures into its component parts or fractions. So this method is also the same with distillation, but the difference is that it can separate many mixtures with different boiling points. Even if the boiling points are very close, it can do the job. Why? Because it has a part called the fractionating column. If you look at this diagram, that fractionating column stops the solvents from mixing together, even though they have close range boiling point. All right. So, assuming we have 3 or 4 solvents mixed together, it begins to boil. Each of them will boil at a different boiling point, and they will be collected differently without mixing together because of the presence of what? The fractionating column. The same principle is applied with distillation. So this fractional distillation is used in the industry for production of dry gin. We use it in separating crude oil, into its fraction. We use it to separate crude oil into petrol, diesel, kerosene, because all these things are mixed together in one called crude oil. So, and they have different boiling points. All right, the next, sublimation. When solids are heated, they change directly into gaseous state. So basically, sublimation is the process of converting a solid directly to gas without passing through liquid. So if we have a mixture of 2 different solids, one of them can sublime and the other cannot sublime. Examples of those things that can sublime are naphthalene, ammonium chloride, or iodine. So these 3 things can sublime. So if I pick any of them and I mix it with chalk or sand or normal table salt, now the ammonium chloride would sublime, leaving behind our chalk. Why is it leaving behind our chalk? Because it can sublime, it can change to gases, so it will be collected as a gas, while chalk will remain there when heated. Now let's look at this diagram. We have a mixture of sand and ammonium chloride, salt. All right. Then when heated, ammonium chloride went out, sublimed, and is being collected in our inverted funnel. Inverted means upside down funnel. We turn it upside down so that we can collect the gases, the solids that are being sublimed into gases, leaving behind every other thing, the chalk, the sand, the salt, and so on and so forth. So basically, you understand what sublimation means. It means separating 2 things that, two substances in which one can sublime and the other cannot sublime. And those things that can sublime are those substances that changes from being a solid to gas without passing through what? Liquid. All right, the next, filtration. In filtration, we separate solutes, insoluble solutes, from its liquid using filter paper. All right. So basically, we use a porous material like filter paper to separate insoluble particles or solid from liquid. And these solid particles that remain on the filter paper is usually referred to as residue, while the liquid that passed through is usually referred to as what? Filtrate. Now let's take a look at this diagram. We have a mixture of liquid and solid, and I have my funnel. I fold my filter paper inside the funnel. When I begin to pour in my liquid and solid mixture, the solid will remain on the filter paper, and that is called residue. Then the filtrate will go down, will go through, or will pass through. That is my what? Filtrate. All right, let's move to the next, decantation. It is a method used to separate liquid and solid particles, which separate into 2 distinct layers on standing. That means we used to separate mixtures that can separate into 2 distinct layers, in which those layers will have upper liquid layer and lower solid layer. All right, then we'll just pour out the upper liquid layer, leaving behind the lower solid layer. Like as you can see in this diagram, we are pouring out the upper liquid layer, leaving behind the sediments, which are my lower solid layer. All right, but this method is very fast but inaccurate. Why? Because It contain after separation, the liquid might contain some particles of solid that would, you know, that would join it after separation, or probably we will not be able to separate all the liquids from the solid. So it is fast but inaccurate. So in the industry, it is mostly preferred, okay, to use filtration because it's more accurate but slow. So we use filtration for water purification, okay, instead of decantation. All right, simple crystallization. This is used to separate salt, which decompose easily on heating, from their solution. Now, this is the principle of crystallization. We mix the salt, the soluble salt in water, it dissolves. We stir until it dissolves fully. Then we heat so that every of the salt particles will dissolve totally. All right, that's my step two. So, step one, dissolve your salt. Step two, you heat until you obtain a saturated solution. The word saturated means you heat until everything dissolves totally. Then step three, you allow to cool. Okay, why cooling? The solids that dissolved because of the heat will now begin to form, come out again as crystals. Then these crystals are then filtered using filter paper. That's our step four. All right, that's basically the principle of simple crystallization. So let's move to the next. Fractional crystallization. This is to separate two or more solids which are present in the same solution in roughly equal amount. So this method is used to separate, you know, exactly the same thing that simple crystallization can do. But in this case now, it separates two or more. No matter how many there are, we can separate it. So all of them would form crystals at their different temperatures. All right. So basically, the difference between simple crystallization and fractional crystallization is as simple separates just few, one or two salts, while fractional crystallization separates many, two or more solids, salts. All right, let's move to the next. Chromatography. Chromatography uses a solvent moving over a porous or absorbent medium, e.g. paper or gel, to separate a mixture of solids. So basically the word chroma means colors. So we use chromatography to separate mixture of colors, basically. So that's the key word there, separating colors. Now we look at this diagram. I have a solvent. That solvent could be water or ethanol. Then I have an ink spot. Okay. Then I have my beaker, and the ink spot is on the paper. That paper is my um absorbent medium. Okay. Now that absorbent medium would place our ink on it, then allow the ink to just be over the solvent slightly. Okay. Then after a while, the solvent will begin to move, going to absorb upward. Now, as it's absorbing upward, it will be taking those ink colors and separating them one after the other. So all the ink colors will now separate differently, showing what you can see in this diagram at the end. So you can see that at our start, we have just one spot. At the end, we saw different spots of colors, showing that the ink is a mixture of colors. So it separates them like that. So that is chromatography. So the paper is my absorbent medium, while my water or ethanol is my solvent. All right, let's move to the next. Sieving. Okay, sieving is used to separate solid particles of different sizes. The usual sieving that you know, using sieve with mesh, we separate solid particles of different sizes, such as rice and beans, sand and rice, by just using your sieve with mesh. The mesh is the holes in our sieve, all right? Like I can see in this diagram, sand and gravel, you can see that the smaller particle, which is sand, is going down while our gravel remains up, all right? Now let's move to the next, separation funnel. This is to separate polar solvent and non-polar solvent. Okay, or you say we used to separate immiscible liquids. Okay, example, immiscible means those things that cannot mix. Example, petrol and water do not mix together to form a single liquid because they are non-polar and polar solvent respectively. So they will separate into two different layers. Then you now release the stopcock, or you say tap. Then the denser one, which is below, will begin to flow down. Then when it gets to the second one, you stop. For example, look at this diagram. We have kerosene and water. Water is denser, so it is below, and kerosene is less dense. So when you release your stopcock, the water will begin to flow down, okay, leaving behind your kerosene. When you're done with water, then you can now collect your kerosene separately. All right, this brings us to the end of today's class, and I hope you have been following. We started with types of changes, chemical and physical. We said chemical forms a new substance, all right, and it is irreversible. Why physical forms no new substance, doesn't form any new substance, and it is reversible. And we entered into different separation techniques. We talked about evaporation, where we recover the solute and sacrifice our solvents by heating to dryness. We talked about distillation, where we recover our solvent, all right? We talked about fractional distillation, okay, separating two or more liquids using distillation. We talked about sublimation, separating those things that can sublime from those that cannot sublime. Talk about filtration, that we use in separating insoluble solid from liquid using filter paper. We talked about decantation, separating mixtures that can separate into two distinct layers on standing. All right. We talked about simple crystallization, separating salts which can decompose easily on heating from their solution. We mentioned fractional crystallization, which separate two or more salts using the same method in crystallization. We talked about chromatography, separating colors such as ink. All right. We talked about sieving, separating solid particles of different sizes. We mentioned separation funnel. All right. We separate those mixture of liquids that do not mix together. All right. Thank you very much for following this class. See you in our next class.